Okay, here's what the rectangle looks like. We labeled the length and the width with L and W. This red line is one of the diagonals. Now let's see if we can get everything in terms of this W. The length of a rectangle is 4 centimeters greater than its width. That means that this could also be represented by W plus 4. And the diagonal is 4 centimeters greater than the length. Well, W plus 4 is the length. 4 more than that is W plus 4 plus 4, or W plus 8. Since the opposite sides of a rectangle are equal, I can put a W plus 4 down here also. So now we have a right triangle with expressions for all the side lengths, and we can apply the Pythagorean theorem. The sum of the squares of the legs equals the square of the hypotenuse. So there's the square of the short side, the width, plus the square of the length, or the other leg, is equal to the square of the hypotenuse. And we have to solve that equation for W, and we'll have it. So hopefully you're good at squaring binomials mentally. Square the first term, double the product of the two terms, plus square the second term. Do the same thing over here. Square the first term, double the product of the two terms, plus square the second term. Quadratic equation. Let's get every term to the left side of the equal sign, leaving a 0 over here. So I see 2w squared on this side. If I subtract 1w squared, I'll get w squared. So now we've taken care of the w squareds. 8w, subtract 16w to get this term to the left side of the equal sign. That'll leave at minus 8w. We've taken care of the w terms. And finally, 16 minus 64 is minus 48. Now, we could try to factor this. We could use the quadratic formula. I could move the negative 48 back to the right side and complete the square, but two numbers that multiply to give negative 48 and have a difference of negative 8 happens to factor fairly simply. So by the zero product property, one of these factors has to equal 0. So that means W equals 12, or W equals negative 4. In the context of the problem, we'll reject this answer since we're dealing with lengths of segments. There's your answer. If you want to double check it, we've got a 12 here, a 16 here, and a 20 here. And if you really want to double check it, you could ask the question, does 12, whoops, this is supposed to be a 12, this is supposed to be a 16. Does 12 squared plus 16 squared equal 20 squared? Well, you might also notice that every one of these side lengths is divisible by 4. So you really have a 3, 4, 5 right triangle, and that definitely is a Pythagorean triple. So this will check. There you go. Hope that helped. If you have any questions, post a comment.